Welcome back to the workshop. This is part 5 of the $75 Dumble build series. Now, where I left off in the last video, I had just finished up wiring up all of the tube sockets, and I was just about to wire up the front panel controls. So I wanted to stop there. The video was starting to get kind of long, and I wanted to start a new one. So that's where we are right now. I did mention at the end of the last video I was using 18 gauge wire for the filaments. And the reason I was using 18 gauge wire was because I thought I had to. I thought that for some reason I got it in my head that 18 gauge wire was only good for 3.5 amps. And this amplifier, because everything is running off of DC in the filaments, gets pretty close to that figure. And I thought I'd be in trouble if I went down to 20 gauge. Well, I was wrong about that. I went and I looked up some data. And it's funny, a lot of different sources will vary pretty widely on their current recommendations for various wire sizes. And so what I did was I kind of took a conservative estimate based on a number of sources that I was looking at. And I've compiled those numbers onto a chart. That chart is going to be available on the website, timkelectronics.com. And it's also got some several tubes listed on there with their filament current requirements. I'm also going to be adding a DIY section to the website. That's going to have some schematics and layouts from various projects, builds that we've done on these videos. So be looking for that. Haven't had a chance to put it up yet, but I hope to be doing that. I hope to finish that up soon. So right now, what I need to get done next is start working on the front panel controls, and I'll show you a couple of things that I got done while the camera was off. So let's go. Now this is one of the things that I got done. Just drilled a hole and mounted that pot. That's going to be our overdrive trim control. I may or may not have mentioned already, but I was going to originally put that on the front panel, and then I decided to put the effects loop jacks on the front panel, so that was going to move to the back panel here, but that would have meant running wires from here across the circuit board and then back, and even using shielded cable. I just felt like that was kind of a sloppy way to do it. So instead I've got it mounted here, and I will be able to access it underneath the chassis when it's in the cabinet, so I still am not going to have to pull the amp out of the cabinet to adjust that, which is nice. And this was the other thing that I worked on, just bringing a screen grid wire up here from the power supply. And these screen resistors that I've got in here right now are 1K 2 watt. And I used 1K because, well, I wasn't really thinking. So I may end up switching those out for some 470 ohm resistors. I guess I was on autopilot. I tend to use 1K resistors a lot because it can add a little bit of extra compression in the power amplifier section. But in this case, I've heard, people prefer the 470 ohm resistors in builds like this, so I probably will switch those over at some point. But that's not something that needs to be done right away. Also, doing something kind of goofy over here. One of the things that I like to do in every build is put a thermistor in line with the primary on the power transformer. The reason I do that is to protect the amplifier from inrush current. And if you put it on the primary of the transformer, you're protecting the entire amplifier from inrush current, not just the HT. This is a thermistor. Basically how it works is this is a negative temperature coefficient. There are also positive temperature coefficient thermistors. This is a negative temperature coefficient, which means that when it's cold, it has a higher resistance. As it heats up, that resistance drops. So this one is a CL60. I just have a bunch of these in stock. I use them in every amplifier that I build. And the cold resistance, I think, is 10 ohms on this one. I could be wrong about that, but it's not really that important. The fact is, just that little amount of resistance goes a long way in protecting the amplifier against inrush current. Now, if you've got an amplifier that has a tube rectifier, then your HT is already protected from inrush current because of the slow turn-on time of a tube rectifier. It has to heat up before it starts conducting. So your HT, all of your power supply filter capacitors are protected from inrush current. I saw a video a couple months ago, and I wish I could remember what channel it was on. It's probably worth a quick search on YouTube, because it was a really interesting video. And the guy actually looked at the inrush current on an amplifier with an oscilloscope and measured the inrush current. And it turns out, on an amplifier with a solid-state rectifier, there is the exact same amount of inrush current whether you use the standby switch or not. So standby switch in that case isn't accomplishing anything except acting as a mute switch. And, you know, do some digging online. You'll find plenty of people who will tell you that leaving the standby switch on for a long time, or rather leaving your amp in standby for a long time, can actually be harmful for your tubes. For that reason, I don't use standby switches in my builds. I use mute switches instead, and I use a thermistor to protect from inrush current. The other interesting thing from that video is he also measured the inrush current on an amplifier that had a tube rectifier. And the tube rectifier did an excellent job of protecting the amplifier, the HT anyway, not the filament, but the HT, protecting it from inrush current, as long as he didn't use the standby switch. When he used the standby switch, it completely bypassed that built-in safety feature of the tube rectifier. So the moral of the story is don't use standby switches. Use these instead. Now, these are by no means perfect, and I've seen some circuits out there that actually have a timed relay to bypass these, because if you're using these to protect your amp from inrush current and your power suddenly drops out and comes back on, because it's already hot, there's no resistance anymore, and you will get inrush current when the power comes back up. So these need to stay cool in order to work properly. However, I don't go to great lengths. I don't put in the timed relay system to bypass this to make sure that it's always cold and ready, because in all my years of playing guitar, I have never once had the power drop out and come back on me. So, okay, maybe once in a great while that might happen and you're going to be unprotected from inrush current, but if you're using a standby switch, you're unprotected from inrush current every single time, and that's going to wear out your components much more quickly. So use these. So in this case, I don't really have a great place to put this thermistor, so I've installed a terminal strip here. So what I'm going to do is just solder this thermistor into this terminal strip, and then I'll bring a wire from this disconnect here over to the terminal strip, and then on the other side of the thermistor bring a wire, or actually probably just tie this. I'll probably end up clipping this off, and well, I don't know if I'll have enough length there. I'll see what I can do, but I'd like to just take this disconnect off and solder it straight onto there. And that way, every time I power up my amplifier, it'll be going through the thermistor. I would have liked to wrap that wire a little bit better, but I was very limited on how much wire I could work with. I didn't want to cut this any shorter than I absolutely had to. So I'm just putting extra solder on there. I mean, you can see I laid it on pretty heavy. Hopefully that'll hold it strong enough. There we go. Okay, and this other side goes on this disconnect. There's a little hole on this disconnect, but this 18 gauge wire is just too thick to fit through there, so I'm going to have to wrap it instead. Over here you can see the wire that was used for the standby switch, and instead I'm going to bring it over to some point here, wherever would make a good mute point, and then one side of this switch will be tied into ground so we can just mute the audio signal from the front panel. But for now I'm going to tie up some of these wires so that they're not just hanging out here. And then of course we still need to tie these wires in. These are the bias supply wires. So one of these goes to ground and the other one comes over here to this diode. Well, you probably can't even see that there. Okay, this diode right here. That's where our bias supply power comes in. So one of those purple wires will get tied in there. Now normally the way I like to do these ground bus bars is bringing them up and above the pots, but in this case I don't have that option because this chassis is a little bit shallower, and I've got to leave enough room for routing other wires up above these pots to keep them out of the way. So in this case I'm actually going to bring them out and over and then back in. And naturally, now I'm running out of bus wire. Dang it. Okay, I guess I'm going to finish this up with some of this wire, since I ran out of bus wire. And it's not as heavy, but it'll work. Well, that wasn't too bad. There was just this one section where I had to use the thinner wire, and this is why I like to use the thicker bus wire. It just stays where you put it a little bit better than that thinner stuff does. And I didn't have to run a bus wire over to the jack here. I didn't have to tie that into the same ground because this jack is coming into this input board with the FET stage, which has its own ground. So now I can start running the wires from this circuit board over to the controls. Okay, this is the part of the build where things start to turn into a bit of a headache, because I've got so many wires coming out of so many different places, and it just becomes difficult to keep track of things. So I've gone through and labeled these shielded cables so that I know what to connect where. Now this capacitor right here is actually the input of the phase inverter, and for now, because we don't have the reverb and effects loop circuits in here, I'm going to tie this this wire in here. This is the wire coming off of the master volume pot. So this is going to be tied in here for now, but once we get everything tested and the reverb and effects loops are installed, then the output of the effects loop return will be installed here instead. And this really is the messy part of a build like this. You've got so many different wires going so many places. Not only does it get confusing if you're like me and you don't have a lot of different wire colors to work with, but it gets confusing because you have to constantly remind yourself what wire you're looking at, and everything's going all over the place, and then you may end up trying to tie things back like this and then realize that one of them was too short, so you got to put a new wire on there. In this case, this one's a little bit too long, so I'll probably shorten that. Now here's a better shot of all these wires here where I tied them up. And you notice a lot of these are not shielded. That's not going to be an issue. Probably half of the ones that are shielded didn't need to be shielded, but you know, those are wires that are running out to the pots and then back to the board, and so it's just a precaution. But there's really nothing over here that can cause any interference except for possibly this right here, and which is why I put these white wires on the other side of these shielded cables, just so that these actually will kind of block any interference from getting to these wires. Okay, so we've got all the front panel controls wired up except for the reverb and presence controls, which I'm going to leave for later. The reverb circuit, I don't even have that built yet, so I can't do anything with that. And the presence knob is something that I can tie in at any time, and I'd rather just, you know, leave as much out of the way for now as I can. I still have to install a speaker jack because these output transformer wires are just hanging there right now. Still have to wire up the bias pot and the... Oh, I haven't even put those test points in for the bias yet, so I'm going to have to do that. I'll put a couple of ring terminals down at this end near the input, and a couple more down by the power transformer, and start grounding things. And then I gotta connect the bias supply wires to this board. And then the last thing I have to do is I've got a couple of these low voltage power supply wires are still just hanging there. And I think I'll probably end up doing those off camera just because I haven't really figured out yet exactly how I want to do that. But anyway, that is it for this week's video. I have a serious case of brain fry from staring at all those wires and trying to keep everything straight, so I'm going to stop there. In the next video, I think we're finally going to be able to plug this in and take some measurements, power it up, and see what we get. I don't know if we'll be able to do a sound sample yet, but I'll try to do that. I'll try to get some sound clips in the next video. So anyway, that's it. Thank you so much for watching. Like it if you like it, comment and subscribe, and we will see you in the next video.